Okay, hi kids. What we're going to do today is we're going to talk about topic 8.6, more graphing with equations. What you need to do is open your book up to page 220 and 221 right now, okay? And then follow along in your book as you follow along in the video. Okay, hopefully you've paused the video, you got your book out, and here we go. More graphing with equations. The book starts out with a question. It says, how can you graph a linear relationship with involving two operations? So we're going to be talking about equations or linear relationships that have two operations such as addition and subtraction, multiplying and dividing, dividing and subtraction, that type of situation. And the situation that they give us is down below. The temperature was 6 degrees Celsius and increased 2 degrees Celsius each hour for 6 hours. The equation y equals 6 plus 2x shows the relationship between x, the number of hours, and y, the temperature. After how many hours was the temperature 10 degrees Celsius? So basically what they're talking about in this situation, okay, this equation shows the relationship between x and y. In other words, you're talking about the x number on the x coordinate and the y number on the y coordinate, and how these numbers relate to each other, okay? And so as x does something, y will do something. You have independent and dependent variables here, okay? So anyways, what we're going to do is investigate some of the things that they're talking about right here. Now here's our problem again. The temperature was 6 degrees Celsius. Okay, so it was 6 degrees Celsius. We knew that. Okay, and it increases 2 degrees for each hour for 6 hours. Okay, so for every hour, okay, it's going to increase 2 degrees. So that becomes kind of a multiplication. So your increase for every hour is 2 degrees, and this would be the number of hours. The 6 is the 6 degrees you started with. So you have to add that as you go. You have to continue to keep that a part of your temperature increase. All right? So anyways, the equation y equals 6 plus 2x shows the relationship between x, the number of hours, and we're going to use these arrows to represent x, the number of hours, and y, the temperature. So we're going to use these arrows to represent the temperature, okay? Now, remember, the temperature is rising at an equal amount each hour. That means that it's rising 2 degrees each hour. That's an equal rise, okay? So it is rising at a steady rate. That's going to create a linear pattern. So if we were to think of it like this, if this were 1 hour, okay, 1 hour passes, then the temperature is going to go up 2 degrees. So you have something going up twice, okay? Then another hour goes by, passes, and the temperature is going to go up another 2 degrees. All right? Another hour goes by, and the temperature is going to go up, of course, another 2 degrees. So you can see where you have your relationship of over 1 up 2. Hour goes by, temperature goes up 2 degrees. Hour goes by, temperature goes up 2 degrees. So you have this relationship that gives you a situation where you have a linear amount, okay? So it goes straight up and down. It goes at a diagonal, but it hits at each of these points right there, all right? So that's what's going on in this situation. There's actually two operations. You've got the 6 degrees that you started with, and then for every hour, you're going to go up 2 degrees. So it's 2 times how many hours you have. So 1, 2, 3 hours gives us a 1, 2, 3, 4, 5, 6 degree rise in temperature. Okay? So anyways, let's take a look at what we have here. Okay? In step 1, they're showing us how to graph this equation with 2 operations. So you can see that we're going to start with the number of hours, which is 0 hours that we start with. Okay, our temperature is at 6 degrees. All right, so then we're going to increase 2 hours. All right, so when we increase 2 hours, we're going to go up a certain number of degrees. Okay, so we're going to plug 2 into there, and it would be 2 times 2. All right, 2 times 2 is 4, plus 6 gives us 10. And then if we have our temperature, if we plot our temperature for 4 hours, we would plug 4 in. 2 times 4 is 8, plus 6 is 14. All right? So now we have our x and our y coordinates. All right? And we can see that after 2 hours, okay, we will have our temperature, okay, of 10 degrees. So now we want to graph each ordered pair on the coordinate plane. Draw a line through the points. Well, our first point, okay, is 0, 6. So we would be at 0, and we'd go at 6 right there. Then we'd have 2, 10. So we would take our temperature over 2 hours, and we would rise up to 10, and we would be right there. All right? And then we have our temperature, we have our hours at 4, and we would rise up to 14, and we would be right there. And so now we've used our equation with 2 operations, and we've established our points, and we draw our line to connect them right in there. So graph each ordered pair on a coordinate plane and draw a line through the points. So we've drawn our line through the point. Now we are right on some intersecting lines if you look very closely. You can then use the graph to find the point with a y value of 10. So this is our degrees, and this is our hours. If we go back to our original question, after how many hours was the temperature 10 degrees Celsius? Well, here's 10 degrees Celsius. We can then take that graph down and say, oh, after 10 degrees Celsius, it occurred. How many hours was the temperature 10 degrees Celsius? At 2 hours, it was 10 degrees Celsius. All right? So use the graph to find the point with a y value of 10. Point 210 is on the graph of y equals 6 plus 2x. The temperature was 10 degrees Celsius after 2 hours. So at the 2 hour point, you were 10 degrees. And all we basically did was start with our 6 degrees temperature. And then, okay, we then filled in our equation because we wanted to know how many temperatures, how many degrees it would go up after a certain time. All right, so hopefully that gave you a better understanding of how to graph 2 equations or 2 operations in a linear equation. And hopefully you were able to say, oh, we can use the y value on a graph to establish the x value. Let's take a look at some of these videos now, or some of these slides right now, okay? Graph this line y 2x minus 1. You're going to probably want to make a simple little graph, and then go ahead and see if you can graph that. Pause the video. All right, let's see how you did. First thing that you're going to want to do is you're going to want to make a table in this situation. Okay? So I just make a simple table like this. I kind of leave it open at the bottom in case I have to extend it. Okay? So I have my x value and my y value. And so there's my table. Okay? Fill in some values for x. Well, in this case, what I'm going to do is I'm just going to start with 0. And I'm going to put 0 in here. And then I'm going to do 1, 2, and 3. 3 will at least establish my pattern. Okay, and if I need to, I can put 4 in there. All right, so I put my values in there. And you're going to use your value to find y. So here we go. 0, 2 times 0 minus 1 gives me a negative 1. 1, 2 times 1, 2 times 1 is 2, minus 1 is a positive 1. Plug 2 in for the x value. 2 times x, or 2 times 2 is 4, minus 1 is 3. 3. 2 times 3 is 6, minus 1 is 5. Got it? So now we have the points on our table, and we can turn those into coordinates. So the fourth thing we do is we plot our points as we go. So we'll take our points, okay, and we have 0, negative 1. So that point is right down there. Then we have positive 1, positive 1, positive 1, positive 1. Then we have positive 2, positive 3, positive 2, positive 3. And right now you can see where we've got a linear pattern going on there. And positive 3, positive 5, positive 3, positive 5. So what we have, and if we make our line through there, make a nice straight line. When you look at this, okay, it goes straight up through like that. And that is a very nice example of going over 1, up 2, over 1, up 2, over 1, up 2. And so when you graph this equation, you can see, all right, what the results are. This is a linear equation, and it would go on and on, okay? You only need 2 points to establish a line, but remember, always go for 3, even 4 sometimes, all right? Okay, let's try another one, see how you do. Another question related to this. Which equation is shown by the graph? Okay, pause the video and see if you can figure out which of these equations is can be represented by that graph. All right, here we go. Let's see. How would you solve this? Well, the first thing that I recommend is that you make a table when you solve this, okay? And you're going to get your x and y values from over here. Well, my first x, y value I'm going to use is going to be 0, okay, it's going to be 2, 0. So my x value will be 2, and 0 will be my y value. Come over 2, don't go anywhere. Then I'm going to use the value of 1, positive 1, positive 1. Positive 1, positive 1. Then I'm going to use 0, positive 2. 0, positive 2. Now, what I can do is I can simply plug in my x values to see if I get the y value. If it doesn't work, then this doesn't, if I can't get the y value that I want using this operation, then I know it doesn't work. Okay? So the first thing I'm going to do is I'm going to say, okay, 2 minus 2 equals 0. Okay? So this works. That's good. So far, that equation works. Then I'm going to take it, I'm going to say, all right, let's put 1 in. 1 minus 2 equals negative 1. Uh-oh. This doesn't work. This doesn't work, okay? So I can say that, all right, that one, right away, I can eliminate that equation. So let's try it down here. I'm going to take my 2, and I'm going to say 2 plus 2 equals 4. So my y value should be 4. Nope, that one doesn't work either, okay? So far, I've eliminated this one and this one. Now I'm going to try this one. 2, I'm going to put my x value in there. 2 minus 2 equals 0. Okay, I've got that. That point works, okay? So let's try the next value. 1. 2 minus 1 equals 1. That works. So far, we've got a working one. Okay? And at this point, I'm going on my third number, so I should be able to get it, hopefully, to work. Plug in x value of 0. 2 minus 0 obviously equals 2, so that works. So at this point, I can probably conclude that my answer, the equation, all right, which equation is shown by the graph, that this is going to be the equation being shown by this linear relationship. I could conclude that it is this one. Okay? Now, if I wanted to, I could check it, and I probably should because I may have made a mistake. I'm going to put 2 in there. 2 divided by 2 equals, so 2 will go into 2. That's not going to work. Okay? That's not going to work. All right? So right away, I can conclude that the answer is C. All right? So anyways, let's take a look at this question. Graph the equation y equals 3x minus 5. Why don't you pause the video, see if you can plot that, make your own little graph, and see if you can come up with that equation graph. All right, here we go. Well, the first thing that you're going to want to do is fill in some values. I'm just going to go ahead and go with 0, 1, and 2. All right, 0, 1, and 2. And when I do that, I can then say, okay, what's my y value? Well, 3 times 0 is 3. I'm sorry, is 0. 3 times 0 is 0. 0 minus 5 is negative 5. Ooh, that's a tough one. 1. 3 times 1 is 3. 3 minus 5 is a negative 2. Okay? And then we have 3 times 2 is 6, minus 5 is 1. Okay? So now I come over here, and I'm going to plot, and I'm going to go 0, negative 5. So I will be down there. Then I'm going to come over 1, negative 2. 1, negative 2. Right there. Then I'm going to come over 2, positive 1. 2, positive 1. Now look at my nice straight line here. That's kind of neat because I have my 3 points there. So now I can take and I can draw my line on there. Just like so. All right? And I can get it on there. And that's what it looks like, right? Like that. Okay? Pretty close. All right? Now, what I could do then is I could also try it with different numbers if I wanted to. Some of you may have decided to go with 2, 3, and 4 as your values. So if I did 3 times 2, 3 times 2 is 6, minus 5 is 1. 3 times 3 is 9, minus 5 is 4. 3 times 4 is 12, minus 5 is 7. Now watch what happens when I use these points, okay? 2, 1. So I'm going to come over here, 2 and 2, 1. Then I'm going to come over here, 3, 4. 3 and 4. Then I'm going to come over here, 4, 7. 4, 7. And isn't it interesting that those points are right there on that line, even if you chose different numbers. Okay? Alrighty. So let's take a look at this one. Raphael graphed an equation which is not a solution to the equation. Okay, so in this case, see which of these would not work on this line. Go ahead and pause the video and see if you can come up with an answer there. All right, here we go. Now, this may look confusing at first, but all you really have to do is ask yourself, okay, x equals negative 4, y equals negative 4. So you could think of it in terms of the table. x and y values.